Hi, so in this video I'm going to show you more examples on how you can use t-student test for a single sample mean. Okay, so this is the idea. Imagine that for some games the football coach collected some scores for the first player and for the second player. So for the first player, for instance, scores were 2, 1, 3, 2, 2, 0, 0, 1, 1, and so on. And for the second player, those were 6, negative 7, 2, 0, negative 10, 11, 12, negative 1, and 5. And just for the sake of simplicity, we do not assume that those were the same games. You can, of course, but our test does not require this assumption to be fulfilled. So, as a football coach, you are interested in which player should be expected to score a goal during the next game. At least one goal, to be more specific. So, we shall start with formulating the proper hypothesis. So, for the first player, the null hypothesis states that the average score is smaller than 0 or equal to 0, and the alternative hypothesis states that the average score is bigger than 0. For the second player, everything looks the same, so we are going to perform this procedure for both players. Please keep in mind that we are interested in verifying whether the expected number of goals is bigger than 0, which means that we go for the right-tailed test. And let us assume that alpha is equal to 0.1. So first of all, we shall define the critical value for the rejection region. Again, it's gonna be the same for two players because we have exactly the same number of observations and we assume the same value of alpha. So for 8 degrees of freedom, because we have 9 matches, 9 minus 1 is equal to 8, and alpha equal to 0.1, the critical value is 1.397. Please keep in mind that we are performing one-tailed test. That's why we do not split alpha by half, and we are not interested in symmetrical negative value. So that's why when it comes to the rejection region, it's everything to the right from 1.397, as mentioned in the table. So the next step is to compute the statistic. So we know that the average score for the first player is 1.33 approximately, and standard deviation is 1. And for the second player, the average score is 2, and standard deviation is approximately equal to 7.45. So using the formula we already discussed before, we can compute the statistic for the mean score of the first player and mean score of the second player. For the first player, the respective t statistic is 3.99, and for the second player, it's 0.81. So finally, we have to choose between the null and alternative hypothesis in case of both players. So let us start with the first player. So this value, 3.99, definitely falls within the rejection region, which means that we should reject the null hypothesis for the first player in favor for the alternative hypothesis. So mean score is actually bigger than 0 for the first player, at least at 10% significance level, because we assumed the value of alpha equal to 0.1. Now, let us analyze whether we can reject the null hypothesis in case of the second player. And we cannot, because t statistic we computed is smaller than the critical value. It does not go within the rejection region. That's why we should report that we do not have sufficient evidence for rejecting the null hypothesis. So getting back to the initial question, our area of investigation, you should rather rely on the first player. because even though the second player has the higher average score, 2 against 1.33, it's less predictable. So you can have some positive value, you can have negative value. By the way, if you wonder whether it's possible, technically yes, in case of autogol. So no problem here. I'm bad in football, but not that much. So yeah, the first player is more predictable, and you can say for sure that you can expect him to score at least one goal during the next game, while the same is not true in case of the second player. Let us consider another problem. So imagine that you analyze the group of patients who took some experimental drug, and you want to check whether their average temperature, body temperature, is different from the normal one, 36.6. You can think about this for a while, and you will indicate that we need to perform two-tailed test. Because again, our research problem is formulated in such a way. It does not really matter whether temperature is bigger than normal or lower than normal. For us, it's enough to know whether it is equal to the normal one or not. So that's why our null hypothesis states that average body temperature is equal to 36.6, and the alternative one states that it is not. And because we go for two-tailed test, and we assume the value of alpha equal to 0.01, when we look for the critical value, the critical t-value, we will have to split alpha by half, which means that we will go for the value of alpha equal to 0.005. So here we are, alpha should be equal to 0.005, and we have 15 degrees of freedom, so our critical value is 2.947. Of course, we are looking for both sides of the distribution because we are performing two-tailed test. That's why those are our regions of rejection. So we will manage to reject the null hypothesis if t-statistics we compute is bigger than 2.947 or smaller than negative 2.947. So let us compute it. And as you can see, it's actually equal to 0.8. By the way, when it comes to mean and standard deviation, you can compute it in Excel, but keep in mind that you should go for the sample standard deviation, and you have to choose the respective command, the respective function. So finally, we go back to the distribution, and yeah, so it's very clear that we do not have sufficient evidence to reject the null hypothesis. And getting back to the initial problem, we should report that no, there is no evidence that average temperature of patients after taking the experimental drug is different from the normal one, which is 36.6. So I hope it's clear now, and thank you for watching.